Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 5 video on the chapter of cubes and cube roots where I will solve the problems of test paper 4 which is given at the end of the chapter in the textbook of author RS Aggarwal. So if you have not watched the previous four parts of the videos on the chapter cubes and cube roots, I strongly suggest that you watch them to have a good understanding of the concepts of cubes and cube roots, and also how the concepts are applied to solve the problems from the exercise of the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the test paper 4 on the chapter of cubes and cube roots. Okay, so I have the test paper on the left hand side. There are A, B, C. The questions are divided into sections A, B, C, A, B, C, and there are total 12 questions. Some are subjective and some are MCQ. So this is based on, so this test paper, every chapter, at the end of every chapter in the textbook of author RS Aggarwal, there is a test paper that which has you can which is a good paper for evaluating your understanding of the chapter concepts. You should always give this test paper, solve the problems from the test paper of every chapter. Okay, so let's start solving the problems. Section A, problem number 1. It is asking to evaluate it is a cube of a mixed fraction. The mixed fraction is 1 and 2 by 5. We have to find the cube. Now, so the first thing is that we have to convert the mixed fraction to an improper fraction. So it becomes 7 by 5. 7 by 5 cube, and we know that this is equal to 7 cube by 5 cube, using the properties of properties of cubes, that x by y, cube of a rational number or a fraction, cube of x by y whole cube is equal to cube of the numerator divided by cube of the denominator. So now it is highly recommended that you should be knowing the squares and cubes of all the single digit numbers as well as a few double digit numbers like 11, 12, 13, 14 up to 15 or up to 16. You should be knowing the squares and their cubes, so that these numbers will be widely used in the given problems. So now 7 cube is if I am not mistaken, it is 343, and 5 cube is 125. Now since the problem was given as a mixed fraction, it was a cube of a mixed fraction, so we have evaluated to an improper fraction. So always it is recommended that you always, whenever the answer is coming as an improper fraction, always express it as a mixed fraction. So this will be I guess 343 minus 240 250 is 39. So this is 293 by 125. I will not check the answer. I might be doing some calculation mistakes, but that is fine. I'm not really bothering about too much careful about calculation mistakes, because my focus is to make you understand how to apply the concepts of the chapter to solve the problems. Okay, so problem number 2 is So as I am solving the problem, you can pause the video and take a screenshot of the solution for your future reference. Uh, Problem number 2 is we have to find the cube root of 4096. 4096. So quickly we have to now whenever you are asked to find the cube root of some number, it is not necessary mandatory that you will find the prime factorization, long prime factorization. It is not necessary. We know that 4096 is easily divisible by I guess it is also divisible by 8. So we can always start by 4, but but you should always perform the long process of prime factorization only when you are asked whether a given number is a perfect cube or not, or in those type of problem where you are asked to find the least number that need to be multiplied or divided to a given number to make it a perfect cube. In those cases, you must completely find all the individual prime factors. Okay. Now, if I divide by 4, I get what do I get? 1, 0, and 24. And this again, if I divide by 4, I get 2, 5, 256. This again 64, and 64 we know is 4 cube. So I can see that this is 4096 can be expressed as we can see 3 fours, 4 cube multiplied by 64. This is equal to cube root of 4 cube, and 64 we also know is 4 cube. So this becomes cube root of 4 cube multiplied by 4 cube is 4 to the power gets added, 6 is 6, or it's okay, or you can express the 4 to the power 6 as an exponential term with power 3. That is, we can say this is 4 square and whole raised to the power 3. 4 square and whole raised to the power 3 is same as 4 to the power 6. Now, so the idea is whenever you are asked to find cube root of some number, or any expression n, where n could be some number, it could be some product of 2 or 3 numbers, or it could be some expression like some variables x, y, z, whatever. If you can somehow express n as some exponential term with a power as a multiple of as power 3, that is some, let's say, x to the power 3. If you can somehow express n as a power of 3, that is x cube, then then this will be equal to x. Then cube root of n will be equal to x. So that is the basic idea. That is why I expressed 4 to the power 6 as 4 square whole raised to the power 3. Now this is cube root of 4 square is 16. So this is 16 cube, and I know that this will be 16. Okay. Let's do problem number 3. I hope everything is properly visible. You can see the problems of the test paper 4. I think it is big enough for you to see properly. Okay. Okay. So problem number 3 is to evaluate cube root of 216 multiplied by 343. Okay. So I will try to express the term inside the cube root as exponential term with the power 3. It could be one term or it could be multiple terms. Like let's say if let's say if you are asked to find the cube root of, let's say, a, and if you can somehow express a as, let's say, x to the power let's say x to the power cube, y to the power cube, and z to the power cube. For example, if you can express somehow a as the product of x cube and y cube and z cube, then definitely I can say that cube root of a will be equal to x, y, z. So this is the idea. So 216, I know 216 is a perfect cube. It is the cube of 6, and I also know 343 is a perfect cube. It is the cube of 7. So we have to find the cube root of 6 cube multiplied by 7 cube. So this is equal to, I can say, 6 into 7 using the laws of exponents, 6 into 7 whole cube. So now this will be 6 into 7, which is equal to 42. Is equal to 42. Okay. Problem number 4. We have to evaluate cube root of, we have a negative rational number inside the cube root. This is minus 64 by 125. Now, if you have something like cube root of x by y, if x and y both are, if you know that x and y are both are perfect cube, irrespective of their sign, x could be negative. That is fine. With ignoring its sign, if x and y are perfect cube, then express it as cube root of x divided by cube root of y. I can see that this is both the numerator and the denominator of the fraction inside the cube root are a perfect cube, because I know minus 64, I know it is a minus 4 cube, and 125 is 5 cube. So this is equal to, now cube root of, I can say, minus 4 by 5 whole cube. So this will be equal to minus 4 by 5, as the concept is cube root of anything a power of 3 cube. X is a cube root of x cube is always x. Okay, and also please note that cube root of x cube is x, and cube root of minus x cube is equal to minus x. Okay. So the section A is done. Section B, let's start section B, which are multiple choice questions. Okay. So question number 5 is, what is a cube of 1 and 3 by 4? So we have to find the cube of a mixed fraction. Now the mixed fraction 1 and 3 by 4, when expressed as an improper fraction, is 7 by 4. So we have 7 by 4 cube. This is equal to 7 cube by 4 cube. This is equal to 7 cube is 343 and 4 cube is 64. Now this is an improper fraction because the numerator 343 is greater than the denominator 64. So we have to convert it back to a mixed fraction. So this will be I think 5, then 20, 32. So 5, 23 by 64. Okay, 5, 23, 5 and 23 by 64. So the correct choice is C. Okay, let's do question number 6. Which of the following numbers is a perfect cube? Okay, let's see all the choices. 121. No, 121 is not a perfect cube because 121 we know is 11 square. So this is not a perfect cube. B, 169. 169 is also not a perfect square because perfect cube, because we know that 169 is hopefully 13 square. So this is not a perfect cube. I will anyway check once again. 13 square, I think 13 square is 169. This is 39 and this is 13. Yes, 169. So 13 square is 169. So 169 is not a perfect cube. C, 196. 196 is also not a perfect cube because it is 14 square. So this is also not a perfect cube. So definitely the last choice has to be the correct answer, that is 216. 216. 216. You must know that 216 is 6 cube. So this is the correct choice. So the cube of all the single digit numbers 1, 2, 3, 4, cube of 1 to 9 and cube of 11, 12, 13, 14, 15, 16, these you must remember as much as possible. Just their squares and their cubes. So the answer is choice D. Okay. Question number 7. What is the, it is asking to find. Question number 7 is a repetitive question. We just did it in, oh no, it is not repetition anyway. So question number 7 is, we have to find the cube root of 216 multiplied by 64. So I will try to see if I can express the given number inside the cube root as terms having power of 3. Terms having power of 3. It could be a single term or product of terms, product of exponential terms where each exponential is having a power of 3. Then I can easily find the cube root. So 216 I know is 6 cube and 64 I know is 4 cube. So this is equal to cube root of 6 cube multiplied by 4 cube is 6 multiplied by 4 whole cube as per the laws of exponents. Now I can say that the cube root will be 6 into 4, which is 24. So the cube root is 24 and the correct choice is C. Okay. Let's do problem number 8. We have to find the cube root of minus 343 divided by 729. Okay. So this is equal to, we can see that both the numerator, the inside we are having a fraction, that is minus 343, not a fraction, a rational number, minus 343 by 729, and the denominator and the numerator, ignoring their sign, they are both perfect cubes. 343 is a perfect cube, 729 is also a perfect cube. So we will express them as cube. So minus 343 will be the cube of 343 is the cube of 7. So minus 343 will be the cube of minus 7. You must be very clear about that. The cube of a negative number is negative and cube of a positive number is positive. So minus 343 will be a cube of minus 7 and 729 is the cube of 9. So this becomes cube root of minus 7 cube divided by 9 cube can be written as minus 7 by 9 whole cube. That is, we can say x cube by y cube, not cube, but in general we know that x to the power m divided by y to the power m is equal to x by y to the power m. So now we can say that cube root of minus 7 by 9 whole cube is minus 7 by 9. So the answer is choice B. B is the correct choice. Okay. Question number 9. is saying by what least number should 324 be multiplied to get a perfect cube. This is a standard question. Okay, so the number is 324, and definitely we have to find the complete prime factorization. So let's find the prime factorization of the number 324. Let's start with 2. So we have 162, and then again we will divide by 2, it will be 81, and then we will divide by 3, this will be 27, and then we will divide by 3 again, it will be 9, 3 and 3. So the prime factorization of 324 is 2 multiplied by 2 multiplied by 3 4 times, and 2 times. Okay, now it is asking the least number that need to be multiplied with. Okay, now if you have if you are following my videos, in my theoretical videos, where I have in the I have discussed this pattern of problem, that what will be the least number to that by what least number should a given number be multiplied or divided to make it a perfect cube. So I explained with some steps how to find the least number. So in this problem we have to find the least number that need to be multiplied with the given number, that is 324, to make it a perfect cube. So first step is we have to find the prime factorization. So we have done it. Now we have to from the prime factorization we have to create the triplets of equal factors. And we can see that the 2 into 2, it is not forming any triplet, so leave it. And from the 4 threes we can create one triplet, that is 3 into 3 into 3 becomes one triplet. I'm grouping the triplet inside a bracket, and we are having 3. Okay, so we can see that the factor 2, the factor 2, 2 and 3, these are not part of any triplet. And we have to consider all those factors which are not part of the triplet, and if such factors, if any of those factors are having multiple times, for example, in this case the factor 2 is having 2 times, which is and both of them are not part of any triplet. So we will then, if any such factor which is not part of any triplet are having more than once, then we will merge them as a power, and we will find we will merge them as power. So we get so the next step is to form all the x to the power m terms, where the prime factor x is not part of any triplet, and if such factor is happening more than once, then those number of factors has been merged as a power m. So in this case we will have 2 square, because the factor 2 was happening 2 times, which is not part of any triplet, to 2 square, and I am having 3 to the power 1. So from the first step was to do the prime factorization. The second step was to form the triplets from the prime factorization, and figure it out what are the factors that are not part of any triplet. So in this case the factors are 3, 2 and 2. Now from those factors which are not part of any triplet, I have to form the x to the power m terms, where x is a prime factor which is not part of any triplet. And why the power m? Because if that factor x is occurring m times, and this m can only be 1 or 2. This m, the possible values of m will only be 1 or 2. So if the term x is happening one time, which is not part of any triplet, then it will be x, or else it will be x square. That is, the term x is occurring 2 times, which is not part of any triplet. So for this problem, so we will make a list of, or we will find those x to the power m terms, and in this problem those x to the power m terms are 2 square, and 3 to the power 1. Now once we have these x to the power m terms, from these x to the power m terms we will find the x to the power 3 minus m terms, x to the power 3 minus m terms. So 2 to the from the 2 to the power 2 will become 2 to the power 3 minus 2, and 3 to the power 1 will become 3 to the power 3 minus 1, which is, so we are having the terms are 2 and 3 square. So finally the least number to be multiplied, that is the answer will be multiplied, is the product of all the x to the power 3 minus m terms, that is 2 multiplied by 3 square. This is 2 multiplied by 9, that is 18. So the number 324 must be the least number by which 324 must be multiplied to make it a perfect cube is 18. And let's see, so the choice is D. D is 18. So therefore the correct choice is D. I hope you got the logic, the concept. I will explain once again. So we are asked to find the least number by which 324 must be multiplied to make it a perfect cube. So the first step was to find its prime factorization, which we did. This is the prime factorization of the number 324. Now from the prime factorization we created all triplets, all possible triplets, and we see mark the factors which are not part of any triplet, which are underlined. So in this problem we are having 2, 2 and 3. These factors are not part of any triplet. Now from those prime factors which are not part of triplet, we will have to create the x to the power m terms, where x is a prime factor which is not part of any triplet, and if that prime factor is happening more than once, which is not part of any triplet, then we will merge those similar x terms as power. So hence in this problem we are having 2 and 2, the factor 2 and 2 is not part of any triplet. So 2 multiplied by 2 is 2 square. So 2 square is one such x to the power m term. The other term is the 3. 3 is happening once, so 3 to the power 1. So 3 to the power 1 is another x to the power m terms. So for this problem we have 2 x to the power m terms, which are 2 square and 3. Now from these 2 x to the power m terms we will create the corresponding x to the power 3 minus m terms, x to the power 3 minus m. So from 2 square we are getting 2 to the power 3 minus 2, and from 3 we are getting 3 to the power 3 minus 2. So we are getting 2 and 3 square. So the final answer, that the least number that need to be multiplied with the 324 will be the product of 2 and 3 square. Okay. Let's do, this was question number 9. Let's do question number 10. Question number, question number 10 is to find, it is given to evaluate cube root of 128 divided by cube root of 250. Now you can see that none of the numbers, 128 is not a perfect cube and 250 is also not a perfect cube. So the idea is to rewrite this as cube root of 128 by 250, because there is a property of cube roots that cube root of x by y is equal to cube root of x divided by cube root of y. Applying this property, we can express cube root of 128 divided by cube root of 250 as equal to cube root of 128 divided by 250, because both 128 and 250, they are not perfect cubes. So once we are having 128 by 250 as a fraction, as a fraction, possibly after doing some cancellation, 128 by 250, we will get a fraction where both the numerator and the denominator will be perfect cubes. So let's see. what happens? What is the simplified form of 128 by 250? Okay, so let's divide it by 2. So 125 and 64. Okay, so this is equal to cube root of 64 by 125. That is, the fraction 128 by 250 has been simplified. After simplification, it is 64 by 125. Now we can see that 64 and 125 both are perfect cubes. Now again, we will rewrite this as cube root of 64 divided by cube root of 125. This is equal to cube root of 64 we know is a 4 cube, and 125 is we know is that is 5 cube. So this is equal to cube root of 4 cube is 4 and cube root of 5 cube is 5. So 4 by 5 is the result. So the answer correct choice is B. Correct choice is B. Okay. Question number 11. Which of the following is a cube of an odd number? Okay. So we know that if we have x cube equals to y, that is, let's say x and y are both natural numbers, and if x cube is y, that is y is a perfect cube and it is the cube of x. Now we know that a property a property of cubes that x is odd, if x is odd, will imply y is odd, and x is even will imply y is even. That is, a cube of an odd number is an odd number and cube of an even number is an even number. So it is asking which of the following is a cube of an odd number. So cube of an odd number. Now a cube of an odd number will obviously be an odd number. So in the given choices we have to select the choice which is an odd number. So definitely choice A is an even number, choice B is also an even number, choice C is not, choice C is odd. So the answer will be 343, that is choice C. Choice D is also an even number. Okay. That was end of section B. Now we have to start. We will start section C, which is fill in the blanks problem. Problem number 12. It has 4 parts. Okay. So it is asking the fill in the blanks is cube root of AB is equal to cube root of A multiplied by obviously cube root of B. This is a property of cube roots we have studied. Where A and B are any numbers, A and B can be positive or negative. This works for both A and B being positive or negative. So cube root of A multiplied by B is equal to cube root of A multiplied by cube root of B. Okay. Part 2 is a cube root of A by B is obviously equal to cube root of A divided by cube root of B. Okay. These are very standard properties. So cube root of negative x. Okay. So cube root of negative x is minus x is equal to negative of cube root of x. So negative cube root of a negative number is a negative number. So cube root of minus x is the negative of cube root of x. Okay. And part 4 is we have to find the cube of the decimal 0.5. Now the cube of a decimal number to find the cube of a decimal number, always convert the decimal number as a fraction. So 0.5 is 5 by 10. 5 by 10, and we have to find its cube. So using the cube of properties of cube, that x by y whole cube is equal to x cube by y cube. So this will be 5 cube by 10 cube. 5 cube is 125 and 10 cube is 1000. So this is equal to, back to, we have to convert the result, express the result as a decimal number. So this is 0.125. 0.125. So this brings to an end of solving the test paper 4, even though there were a very small number of questions, but these questions will brush up the fundamental concepts and formulas of the chapter of cubes and cube roots. So this brings to an end of the chapter cubes and cube roots as far as following the textbook of author RS Aggarwal is concerned. Now I will prepare 2 sample test papers 1 and 2 on the chapter cubes and cube roots, and also I will keep on preparing and solving 10 good problems in the playlist Maths 8 Hot, where I solve 10 good problems for every chapter for all the chapters that I finished covering in the playlist CBSE Maths 8 RS Aggarwal. So also look out that playlist, that is Maths 8 Hot, where I solve 10 good problems every now and then for all the chapters that are finished, all the chapters that have already been covered. So they are, and those 10 good problems are, they will be coming every now and then, so it will never stop. So I will try my best to keep on preparing 10 good problems and solve them for all the chapters that I will cover. So I hope this video was beneficial. If it is, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will see you soon in the next video, where I will solve the first sample test paper 1 on the chapter of cubes and cube roots. So until then, take care and bye.